My name is Jeffrey Yelton, and this is a video abstract from my paper entitled Images of Two-Adic Representations Associated to Hyperelliptic Jacobians. In this paper, I examined the natural Galois action on the two-adic Tate module of the Jacobian J of the generic hyperelliptic curve degree 2g plus 1, given by this equation, whose roots alpha sub 1 through alpha sub 2g plus 1 are independent and transcendental over some ground field k. We may consider J as an abelian variety of dimension g over the function field capital K, which is little k adjoin alpha sub 1 through alpha sub 2g plus 1. We first assume that the ground field K is the field of complex numbers. In that case, the image of the Galois action is contained in the symplectic group, corresponding to the Weil pairing on the two-adic Tate module T sub 2 of J. Since the two torsion points of J are defined over capital K, the image of the Galois action is actually contained in the level 2 principal congruent subgroup gamma of 2, consisting of the symplectic automorphisms equivalent to the identity modulo 2. The main question that this paper addresses is whether this image in fact is equal to gamma of 2. In other words, whether the Galois image in the generic case is as large as possible. This was already well known to be the case for elliptic curves. For hyperelliptic Jacobians, it was well known that the endomorphism ring in the generic case is Z, making it possible for the two-adic Galois image to be large. Zarhin has given examples of families of hyperelliptic Jacobians defined over a field finally generated over Q, such that at each fiber the two-adic Galois image is a finite index in the symplectic group. However, no bound on this index was known. This paper shows that the two-adic Galois image in the generic case does, in fact, coincide with gamma of 2, and is therefore literally as large as possible. The method used is to consider the family of degree 2g plus 1 hyperelliptic curves over C, parametrized by the set of roots, and to use a topological result proven independently by Mumford and by Ocampo, which states that a certain monodromy image coincides with gamma of 2, and to translate this topological result into the arithmetic result that we want. Now, this result may be generalized in the case of any ground field K of characteristic 0, which contains all 2 power roots of unity. Using a suitably strong form of Hilbert's irreducibility theorem, one can show that the Galois image is also as large as possible in infinitely many special cases, where the roots of the hyperelliptic curve lie in some number field. I further use the above method to show that the field of definition of foretorsion for the generic hyperelliptic Jacobian is given by joining square roots of the differences of the roots alpha sub 1 through alpha sub 2g plus 1. The formula determines the Galois action on the subgroup of foretorsion for any hyperelliptic Jacobian defined over any field of characteristic different from 2.